Oops.
9, all. All right, we're going to go to chapter 5.
Okay.
And okay, so an important concept of economics is this notion of diminishing marginal returns, right? And so what we're talking about with these diminishing marginal returns is we're really talking about, so we're going to refer to table 5.1. Which talks about how, if you're eating ice cream, and this is the quantity of the ice cream that you're eating. if we had some sort of way to value that quantity, right? And so what we do is we make up something called utility, right? And so this is going to be our total utils, U-T-I-L-S. So it's a very new concept for us, right? And it's just kind of this made-up thing that economists created so that we could talk about, the fact that some goods bring us joy, like ice cream, and other like goods don't bring us joy, like having to get triple bypass surgery or pollution or something like that, right? And so, with respect to kind of the foundations of demand, right? It really comes out of this conceptualization of utility, right? And so we tend to think that humans, overall, we have this diminishing marginal returns to utility. So what exactly does that mean? That's a good question. Let's go ahead and I'm gonna alternate for the sake of clarity. Hopefully this orange one shows up well. So we've got 0, and at 0, we're at 0, right? And then at 1, we are going to be at 50. So she gets 50 utils from eating 1 ice cream cone. When we're at 2, we then get 90 utils, right? And so real quick, before we even go any further, what's happening here? The utility that Sarah, in this particular example, the utility that Sarah is getting from eating ice cream is still increasing, right? It went up by 50 for the first ice cream cone, right? And then the second ice cream cone, it went up by 40. So it's still increasing, right? It's still increasing by positive 40. But is that positive 40 the same utility? Like, is she getting the same extra utility out of the second cone when she's already eaten the first as she got from the first cone when she's already eaten when she hasn't eaten any? And the answer is no, right? So as she continues to eat ice cream cones, the utility, the enjoyment of it decreases, right? And now what a lot of, very, very discerning students will say here is, well, that doesn't quite make any sense. What if she waits a while before eating the ice cream cones? Or what if this is talking about, the ice cream cones that she has in a week or a month or something like that, right? Which brings us to a very good point. In all of economics, we have to define the time period, right? So when we talk about gross domestic product, we talk about all the final goods and services produced in the United States over a given year, right? And so I actually, trying to be a little, save some space up here, I cut something out. This is actually ice cream cones per hour. And this is not a very good marker. Per hour. And this is also utils per hour, okay? And so that starts to kind of jive with our intuition in terms of, you're going to get full, you might not be as hungry anymore, you might want a different flavor, you might get an ice cream headache, right? There's a lot of different things that may happen. And so let's just keep going. So 3, we've got 120. So it goes down by another 10, right? 4, we've got 140. Again, another 10. So on and so on. Well, let's just keep going. 5. Sorry. 5 is going to be 150. And then what happens when she hits 6? So 6, the total utility that she gets eating 6 ice cream cones is 140. So she's actually losing utility when she goes from eating 5 ice cream cones to eating 6. And this doesn't always happen, right? We don't always get in the range. Like, she might not be able to eat 6 ice cream cones. She's going to puke before that, right? Or maybe that's actually what it is, that when you eat 6, you end up getting some really bad indigestion or some gas or something like that, right? And that's why your utility goes down. So it's important to keep in mind that for the most part, utility is still, well, for all of this relevant range right here, right? The utility is positive. So no matter what, by eating any number of ice cream, you're going to be better off, right? You're going to be, living your best life and everything like that. It's the fact that the rate at which, right? So the derivative, the rate of change, so, our acceleration compared to our speed, right? So this could be, think about it as our speed, and our acceleration is eroding, right? So every time we eat an ice cream, the what's called our marginal utility, right? This is called our marginal utility. And so marginal is this word that trips up a lot of students. And I always tell people, just replace it with incremental. So this is our marginal utility. And again, this can be just replaced in your mind as incremental. And so that just means the utility that I get from the next one, from the next particular thing. And so if we were to graph this, we would end up with what's called a concave curve. And I'll give you a nice little hint on that in a second. 1, 2, 3. Good. I'm still getting used to this. So, and then 50, 90, 120, 140, 50. So we've got 150, 2, 90, 3, 120, 4, 140, 5, 150, 6, 140. So this curve that we get, and then at 0, we get 0, right? And so this curve that we get is increasing, but look at the slope at first. This slope is super, the rise over run of it, right? In terms of, if we were to look at the slope, the rise over run, it's something like 3 rise over 1 run, right? And so what's happening with this convex curve, and what's happening with the diminishing marginal utility, is this slope is decreasing over time. So the slope is the marginal utility. And so the marginal utility goes from being 50 to 40 to 30 to 20 to 50 to, to 30 to 20 to 10, and then to negative 10. So this last marginal utility actually ends up being in the negative range of things, right? And so oftentimes we can combine these two graphs. And so we already have some of our marginal utility stuff, right? We've got, 50 and 40. And then here, let's keep doing it. We've got, then it's 30. And then it's 20. And then it's 10. And then lastly, it's negative 10. And so these are all the marginal utilities for the next good, right? So there's no actual marginal utility for 0, because it's not like we're going from -1 to 0 somehow, right? So the 0 marginal utility. So if we were to rewrite this, which I think we should, eraser somewhere. We could do it like this. So this is kind of more the presentation you'll see in the book. So it's going to be nothing, right? There's no marginal utility of 0 ever. Then it's 50, 40, 30, 20, 10, negative 10. And so what we can do is we can also graph that marginal utility. And what we find, this is not ideal. What we find is that it starts off up here, and it's going to be kind of this constant slope. Now, it's not always a constant slope. That's just the way that this particular example kind of fell out. And of course, I can't draw a straight line right now. But that's essentially a straight line. And this is our marginal utility curve, whereas this is our total utility. So any questions on that? The difference between marginal and total utility, and just the notion that our utility is going to be increasing at a decreasing rate over time, right? So this is all kind of detailed in the translating wants into demand portion of the e-text on page 118 to 122. Any more questions on that? Well, we're gonna keep going. Law of diminishing marginal utilities. Okay, so now we are asked. So we're gonna go. Any questions on that before we move on?
No question.
Oh, awesome. So now we're asked. So is Sarah maximizing her utility from consuming chocolate and vanilla ice cream, right? So this is example 5.1 in the text on page 119. And this is saying, is Sarah maximizing her utility from consuming both chocolate and vanilla ice cream? And so we're given some very important information that we need. We can't do this question without the information, right? We're told that chocolate is $2 a pint. We're told that vanilla is $1 a pint. And we're told that we have a budget of $400 per year to spend on ice cream. And then the last bit of information, this just gives us the kind of budget situation, right? This doesn't actually give us any of her wants, right? This just tells us, you know, what the situation is in the market. So we need to then use our figure 5.3, and so I will recreate that just below here so that we can figure out the marginal utility for the two flavors of ice cream. And so the marginal utility of chocolate, let's do vanilla first, since that's thicker. So this is, I don't like this color. Tall. Okay, I'm just gonna have to not do these are pints per year. And we see that at 200 pints, that's essentially my maximum, right? If I just, you know, spent all my money on vanilla ice cream, oh, actually that's not true. If I spent half my money, since vanilla is $1 a pint, if I spent half my money on vanilla ice cream, then I get 200 pints of vanilla ice cream, and I have this curve it's already like given to us, right? That says that at 200 pints of ice cream per year, my marginal utility that whole year is going to be 12. Or sorry, not for the whole year. This is your marginal utility utils per pint. That's pretty low. 12. So it's going to be 12 utils per pint, right? So the total utility is going to be 12 times 200, right? Which would be 2,400. Now, what about chocolate, right? What about chocolate? So chocolate, we've got same thing, pints per year. Got marginal utility in this chocolate. And this is going to be a steeper curve. And again, that's just that's given to us. Sorry, I'll use black for that. Again, it's given to us. You know, we're not going to need to calculate this. Again, what if we spent half of our money on chocolate ice cream, right? Since chocolate ice cream is $2 per pint, half of our money means 100 divided by 2 divided by 2, which gives us 100, right? Because half of our money is 200, costs $2 a pint, so we can only get 100 pints at $2 a pint, that's $200. We can split it in half. And this is giving us utils per pint. So what do we think is going to happen? So her spending yields higher marginal utility per dollar for vanilla than for chocolate, right? Because even though this is a lower marginal utility, this is 12 marginal utilities per $1. This is 16 marginal utilities per $2. Right? So the actual marginal utility per dollar for chocolate is going to be $8 per pint. That's her marginal utility for chocolate. Again, that's because the chocolate is costing $2 per pint. And so this is 8 utils per dollar. This is right now 8 utils per pint. And okay, here's what I'm gonna do. So we've got 16 utils per pints, right? And then we know the price is $2 one pint. It's going to be $2. $2 per pint. All right, so one pint for $2. There we go. So the pints are going to cancel out, right? Boop, boop. And then we end up with 16 divided by 2 utils per dollar. So it's going to be 8 utils per 1 USD per dollar. So hopefully that's a little clear how we got to that calculation, right? So this is for chocolate. And the vanilla, we can do the same situation, but it's not nothing, right? It's 12 utils per pints. It's 1 pint per $1. So the pints don't cancel out. We just end up with 12 utils. So as a result, Kara cannot possibly be maximizing her utility. And to see why.
Sorry.
And to see why, you can kind of do a mental exercise. What if she spent $2 less on chocolate?
Thank you.
$2 less on chocolate would mean that she would lose out on what? 16 of these utils. And with the same $2, what could she do? She could go buy 2 12-util pints of vanilla, giving her 24 utils extra, right? So the net gain, yeah, she gave up 16, but she got 24. So that's a net gain of 8 utils. Anytime there's a way to change your consumption bundle that increases your total utility, you're not optimizing your utility, right? You're not maximizing your utility in that situation. Does that make sense? If you can make a change that benefits you in terms of giving you a higher utility, then you're not maximizing. What is the optimal amount of ice cream for Sarah? And so for this, again, there's some information that we don't necessarily have. We don't have these values up here, right? And again, this is just an example from the book. But jumping ahead, right? So if this was on graph paper and you could see all the different marginal utilities and all the different combinations of stuff, right? Then we skip to figure 5.5. This one is showing me the marginal utility of vanilla ice cream when I'm consuming more vanilla ice cream, right? So when I'm at 250 pints per year of vanilla ice cream, then what is my marginal utility of vanilla in utility per pint going to be? It's going to be above 12 or below 12? According to our law of diminishing marginal returns, if we increase something that we're consuming, are we going to have a greater marginal utility or a lower marginal utility? So that's right, we're going to have a lower marginal utility, right? Because of the fact that, if we go back to that original example that we did at the beginning, the first ice cream gave her 50 utility, right? The second ice cream gave her 40 units. The third ice cream gave her 30, right? And so as we increase consuming ice cream over any given period of time, even something as broad as pints per year, marginal utility of it is going to decrease. So when we go from 200 to 250, and we can also see that by the slope of the curve, right? It's a downward sloping curve. So we were previously over here at 200. And at 200, we were at 12. And so it's a downward sloping curve. So as we get further out in the x-axis, we just have to have a lower value on the y when we reflect it off of the curve, right? It just makes sense. But again, we didn't have all this information given in the prompt to us, right? So it's kind of difficult to do this without without complete information, without more detailed graphs. But I'm just trying to make sure you guys are kind of catching the feel and the jive of things right now. Okay, and then look at that straight line. That's beautiful. So then we got a marginal utility of chocolate, right? And this one, remember, it was a bit steeper. And before we were at 100, right? Before we were just saying, I have no idea what the optimal mix is. I'm just going to split my money in half, and I'm going to buy half vanilla. It's not really half vanilla and half ice cream or chocolate because chocolate's more expensive. But I'm going to split my budget down to income, and I'm going to spend half of my income on half chocolate and half of my income on vanilla, right? So that was just kind of our initial guess, right? And so remember, when we were at 100. Wow, that's orange. We were at 100. What was our marginal utility? It was, I think, 16? Yeah, 16. And so if I decrease, okay, number one, if I'm increasing my pints per year of vanilla, right? I should probably put that somewhere here. This is vanilla. This is chocolate. So if I'm increasing my pints per year of vanilla, am I gonna be increasing or decreasing my pints per year in chocolate?
If you're increasing your vanilla,
Increasing my vanilla, what
Oh,
has to
you-
happen to my chocolate?
decrease it.
Gotta go down, exactly. Yeah, I only have so much money. I'm not making any more money. There's no credit. I'm not begging. I'll pay you back next year or something like that for the chocolate ice cream, right? I have a budget.
Okay, Tuesday for hamburger today.
Exactly. Very good. Yes, that's actually in one of the bars here in Chadron. That quote. So we're gonna have to buy less chocolate, right? And at a lower consumption of chocolate, what's going to happen to our enjoyment of chocolate ice cream, right? Like as it becomes more of this, special treat that we only, give ourselves when we worked out or whatever the case may be, right? What's going to happen? The utility is going to increase, right? So that diminishing marginal returns of utility works in the other way as well. So if you go from consuming a lot of something and you kind of scale back a bit, your enjoyment of that good increases, theoretically.
That makes sense.
All right, good. So, so now let's try to do that same kind of mental exercise before, right? What did we do before in order to figure out, is she living that best life? Is she eating that greatest, that sweetest combination of vanilla and ice cream over a year? And so what did we do before? We said, well, what if she gives up? Well, hold on. Before we do any of that, what do we need to do? We need to get these into apples and oranges, right? Because all of this stuff over here is all, talking about per $1 pint of ice cream, right? And all this stuff over here is talking about per $2 pint of ice cream, right? So what do we need to do? We need to get this in common units. We need to get it into, what did we have before? We need to get it into utilities. Utils per dollar. Utils per dollar, right? So how do we get to utils per dollar? Well, we're going to use this value over here. This over here, these are my utils per pint. And so I've got 10 utils per pint. And I've got $1 per one, or crap, I keep doing this upside down. 1 pint per $1. And the pints cancel out. And we end up with 10 divided by 1 utils per dollar. So it's just going to be 10 utils per dollar. Sometimes I just write USD instead of dollar. Hopefully that's okay with everybody. There's many dollars, so I like to clarify it's the United States dollar. All right, and then what about our chocolate one, right? So our chocolate one, we've got 20 utils per pint. And this one, we've got 1 pint per $2 US. And so this one, the pint's going to cancel out. We're going to get 20 divided by 2, so 10 utils per US dollar. And look at this magic. They are equal. Woo-hoo. That's what we want, right? That's exactly what we want. If they're equal, then that means that switching from chocolate to vanilla is not going to get me any extra utility. I am at the highest utility, total utility that I could possibly get from the combination of these two goods. And my particular preferences, right? And how are my particular preferences represented? They're represented by these curves, right? So you know, some very, you know, well-paid, smart, nerdy programmer people spend a lot of time estimating these marginal utility curves, which are essentially, which we're going to lead into, which are essentially demand curves, right? And so at the end of the day, the thing that we're doing right here, at the bottom, this is nothing more than what's called the rational spending rule. The rational spending rule is saying that the marginal utility of a good A divided by the price of a good A should be equal to the marginal utility of good B divided by the price of good B. Now, I know a lot of students see this and they get a little freaked out, right? But it is nothing more than what we did over here in terms of, I wish I could like snap these boards in half. Paper, I think I might go back to paper for next class. It's a lot more malleable. But it's nothing more than this, right? It's 10 divided by the price, 20 divided by the price. I just wrote out the units there because my dyslexic mind likes to multiply instead of divide, right? And so I do this kind of trick I learned from chemistry, right? Where you know you
Works for
write
me.
out all of the different what are they called? Units. Yeah, units. You write out all the different units and you find and you arrange it in such a way that things cancel themselves out and you end up with utils per dollar. And so this is just kind of a shortcut to that, you know? It's instead of, you know, and either one is going to work though. If this works better for you in terms of, you know, the kind of chemistry approach, and that's fine. If you just want to, you know, cut to the chase and you know what the marginal utility and the price of both of them is, and you want to see if they're, you know, if allocation is optimal, you can just, you know, plop them in there, see if they're equal. If they're not equal, then there's some rejiggering required to optimize that total utility.
No, I do it the same way you do.
Good.
It takes an extra step, but
It just makes more sense. It's easy to get.
it does. I have to do it the long way. My college algebra teacher told me that he said I always get the right answer, but the way it is if he asked me to drive from Cheyenne to Denver, it was like I went from Cheyenne to Denver by way of LA.
I mean, you know.
But I got there.
Your brain might be faster at doing that than it would be just, you know, Cheyenne to, you know what I mean? Like it's not.
But at least I got the right answer.
Exactly. Yeah. And I think that's an simplification of the way that our neural paths actually work in reality. You know what I mean? And I think that it's not a big deal to take that long way, and eventually that long way becomes the fast way to you. You know, and then
Yeah.
you don't actually, you know, have that, you know, negative impact or whatever that, you know, he might have been trying to warn you about or something.
Yeah, I have to think. My husband can look at it, and he doesn't even have to work things out on paper. He just does it in his head. He looks at it and knows the answer. He has one of those weird math brains.
Right. And my brain's pretty good like that too, but I'm a very visual person. So like, you know, when I was in grad school and I was studying with people, and they would say stuff like, you know, oh well, can you help me with this derivative? It's, ln of x squared plus, and I'm like, no, just give it to me. Like, you reading
Yeah,
it,
I write it down.
like, it's just frustrating, like if I see it, then I understand it. Even same thing like with new words. Like if somebody introduces a new word to me, I'll have them spell it because I can't remember it or,
Me
think
too.
about it unless it's visually kind of locked in there. So yeah, everybody's got their own little picadillos, and there's nothing wrong with that. That's again, if we were all the same, there would be no economics class, right? We would all be buying the same products. There would be no diversification of markets and things like that, right? The heterogeneity, the differences that kind of define us is really what makes economics such a dynamic and complex and interesting science, right? So at the end of the day, we really are quite grateful that we're all so different.
We need teams.
Yeah, exactly, and different different ways of attacking things that have different outcomes, and sometimes no one outcome is the best, and sometimes it's a combination of outcomes that's the best, right? That's what we seem to be finding with neural net programming and with advances in artificial intelligence, right? It's not that the best chess player in the world is an AI, and it's not that the best chess player in the world is a human. The best chess player in the world is not a player; it's a team.
Mm-hmm.
AI and human team combined, right? And so we're really finding a lot more about the collaborative nature of the economy rather than the competitive nature, which has been highlighted for the last couple hundred years, right?
Yeah, it's funny you mention that about AIs. I've been reading a series of books about this super intelligent AI, and it's funny because he still needs people. He makes fun of people, calls them meat sack caveman, hairless monkey boys.
Right.
But he forgets things like, when they're in space, he'll work out these solve these super complicated problems. He can do anything, but he forgets that when he sends a human out into space that he needs a spacesuit. He'll forget something like that.
Right.
Human to tell him those things, but yet he can, bend space and time and open and close wormholes and things. But
So it's the stereotypical, no street smarts, all brain smarts kind of situation there.
Yeah.
That's cool. What's the series called?
Expeditionary Force.
I've actually heard of that. Yeah. I should check it out. I'm always looking for new authors.
Yeah. He's hilarious. His name is. He wanted to be called the Lord God Almighty or the Great and Powerful Oz, and so the guy who found him says, "You're such a butthole. I'll call you Skippy."
That's awesome. I love it.
Yeah. He's really funny.
So how do we actually get? So why do we care about this marginal utility, right? We're in a chapter about demand, Chris. Why do we care about this? Well, at the end of the day, what are these marginal utility curves? They're demand curves. They're individual demand curves, right? Because what the marginal utility, if we translate marginal utility into dollars, which is always kind of a tough thing but it's totally possible. You can translate marginal utility into dollars. Economists do it all the time, right? And so by getting a feel for the marginal utility of stuff, that's going to let us know how much people will buy at different prices, right? And we all know that there's a law of demand, right? What's the law of demand? It's the fact that as the price decreases, people want more of it, right? So when the price is 1.6, this is for cans of tuna. So when the price is 1.6 for a can of tuna, nobody's going to want it. It's too expensive. Smith is not going to want it, right? Smith says that's too expensive for me. But when the price is 120, he's going to say, okay, yeah, I'll buy 2 cans a week. And when the price is 80 cents, he says, okay, sweet, I'm going to buy 4 cans a week. And so, and this behavior, right? That as the price decreases, the quantity increases. That's the law of demand, right? The other way to remember what's going on with the demand curve is that demand is downward sloping, right? And demand starts with D. So if you ever forget which one is which, mnemonic, right? It starts with B, it's going down. Okay. Oh no, should have left that. Smith. Okay. So this is just, this is just one guy, right? And then we've got Jones. And Jones, she would, we're gonna go Martha Jones from Doctor Who here, right? So Jones, she would buy it, not at 0.8, right? At 0.8, that's too expensive. It would have to be 0.4 or 0.6 rather for her to buy one, and then it would have to be 0.4. It have to be 40 cents for her to buy two, and at 20 cents she buys three, and so on. Okay, so she has much less of a utility assigned to cans of tuna. And again, so why do we care? Why are we digging down, so minutely, right? So granularly. Well, at the end of the day, a demand curve is nothing more than a horizontal summation of these curves. And so I'll show you what I mean by that, right? So let's say, and I know that this is not the case at all, but let's say that Jones and Smith are the only two people that buy tuna in this economy. And so this is the market for tuna. And this is dollars, and this is quantity. Try to get in the habit of, writing the L, using the arrows, labeling both curves, labeling both axes, right? A way to figure out, so I have a hard time with, left-right dyslexia. And so the way that I like to figure out what's going on, which needs to go which, because does the price go on the y-axis or the x-axis, right? So this is what I do. I use the alphabet, right? I sing the alphabet song to myself, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, right? So the P comes before the Q in the alphabet song, and the P is to the left of the Q in the graph. So if you remember the alphabet song, you know where to put the P, where to put the Q. Make sense?
Yes.
Cool. And so, so you always want to label each curve. You always want to give it a title. And then back to what we were actually doing. So how do we figure out the market demand? Well, we're literally just going to take Smith's demand at a particular price, add Jones's demand at that particular price, and that's going to be our market demand, because we simplified this so that there's only two people in the whole market. So so we start at 160, right? Because nobody's buying it before 160. And we know that because that's where Smith's curve starts. That's why we start at 160. But nobody's buying it at 160. That's our kind of origin point there. And so, but what about at 140? So at 140, we know that Smith is going to be buying, 1. And at 140, Jones, right? At 140, that's all the way up here. Jones is buying nothing. What about at 1.2? At 1.2, Smith's buying 2, Jones is buying nothing. 1.2. And so on and so forth, right? Until we get to 0.8. When we get to 0.8, so this is Smith's curve right here, right? But since it's the market curve too, because at this point, for this price range, when tuna is between 0.8 and 1.6, 80 cents and $1.60, Smith is the only person buying tuna in the market. So that's why the market demand curve for this range looks exactly the same as Smith's market demand. Now, as soon as we get to 0.8, well, actually, as soon as we get to 0.6, rather, right? Because 0.8, she doesn't buy any. When we get to 0.6, Jones is in the game, right? Jones is now purchasing a can of tuna. They're only purchasing 1, right? When we're at 0.6, how many cans of tuna is Smith purchasing? Smith looks like he's purchasing 5. So 5 plus 1 is 6. And so at 0.6, our value, and so there actually should be kind of a little kink here in a way. Because at 0.6, now we've got Jones and Smith in the market. Smith is going to be consuming 5, Jones is going to be consuming 1, and so we're going to have a total market consumption of 6 cans of tuna. And going on, going more and more at 0.2, right? At 0.2, Smith purchases 7, Jones purchases 3, and so our market demand at 0.2 is 10. It is literally just combining the individual demands for all of the consumers in the economy. Now, let's put it all together. So this is figure 5.11. This is talking about milk. This is dollars per gallon. This is quantity. This is 1,000 gallons per day. That's not the abbreviation for gallons. Please forgive me. And then we're going to have a what's our demand curve? Is it upward or downward sloping?
Down.
Downward sloping, exactly, because it starts with D. And just because of the law of demand, right? As things become cheaper, more people are going to want them. And so we're told that this starts at $3. We have a couple of values here. We've got 250 and 2. We've got $2 and 4. We've got $1 and 8. $1 and 8. All right, it's probably good enough. Okay, and now we're gonna draw in our supply curve as well, right? Our supply curve, and so our supply curve is always going to be upward sloping. It's going to start at the origin, and our supply curve is nothing more than our marginal cost curve of all the individual firms, right? So especially like in a perfectly competitive market, they're going to be selling at the marginal cost because of competitive forces and things like that. So the supply curve, again, nothing more than the marginal cost curve. We'll call it the supply curve here for right now, just for keeping with figure 5.1. So what's going on here? First of all, is there an equilibrium? Oh wait, sorry. Whatever the heck I pleased, didn't I? Is there an equilibrium, and what is it?
$2
$2, and what's the quantity?
for 4,000 gallons.
Very good. So the price, P star is $4, and the quantity star is 4,000 gallons. Awesome. And so at this particular equilibrium, we are asked what the consumer surplus is.
No, it's $2.
Oh, thank you. And so we're asked what the consumer surplus is, right? And the consumer surplus is, so we have to think about, remember, we have that individual demand curve, right? We have, and these demand curves, they're really representative of our both our marginal utility and something called our willingness to pay. right? Our willingness to pay. And so this demand curve, so what this is telling me is that there's 2,000 gallons that's demanded at 250, right? So there's some people, I don't know how many people, because I don't know how many gallons of milk people drink a month or whatever, you know what I mean? But there's a bunch of people that are willing to pay $2.50 per gallon of milk, right? But what are they actually paying? They're actually paying $2. And so that difference between the $2.50 and the $2, that is what we call our consumer surplus. It is the willingness to pay minus the equilibrium price. And so this is going to happen for each one of these things, right? There's, at 1,000, there are some people that are willing to pay, $2.75, right? But they're only paying $2. And so that's, if we look at all the full 1,000, right? That's 1,000 times, if we say that this is 2.75, then that's 1,000 times 75 cents. That means that just in the first 1,000 units of milk sold, there's $750 of consumer surplus generated. And at the end of the day, we want more consumer surplus, right? So Adam Smith, the founder of economics, right? He wrote The Wealth of Nations in 1776. Economics was pretty much wrapped into politics. It was part of political economy before. He had a very revolutionary, he had lots of revolutionary notions. But one of them in particular that's related to what we're talking about here is that he was not a person for labor. He was not a person for capital. He was not a person for the farmers, right? There were all these different competing interests and all these different, economic, demagogues and ideologies that were going around, substantiating and destroying, other people's, views and worldviews and so on and so forth, right? And Adam Smith instead said, we're all consumers. Doesn't matter if you're a laborer, if you're a capitalist, if you're a farmer, we're all consumers at the end of the day. And so the main kind of goal of his research and his inquiry was to benefit the consumer. And that's really, the consumer surplus is one of the ways that we can, kind of concretize, crystallize that particular, vague notion of, well, I would have paid more for this, but I didn't have to. And since I didn't have to, that extra money that I'm getting, that is, kind of a boon to the consumer class, so to speak. And so if we needed to get the full consumer surplus, right, well, what we would do is we would just figure out this triangle. What's the area of this full triangle? And so this is going to be 1/2 base. The base is 4,000 times, and then the height of the triangle, right? It's 3 minus 2. The top of it's at 3. The bottom of it's at 2. So it's going to be times 1. So it's going to be $2,000. Half of $4,000 is $2,000. So we get a consumer surplus of $2,000 at this particular equilibrium. Any questions?
Got it.
Cool. I think that should be enough to help get y'all through the forum post this week. Pretty sure.
Okay.
But if you have any other questions, feel free to email, and I'll be happy to answer any way I can.
Very helpful. Thank you.
Very welcome. All right. I'll see you next time.
Have a good day.
You too. Bye.